You know that little moment of pure magic when you just look at your phone and poof, it unlocks. That's face recognition, and honestly, it feels pretty much flawless. But what if I told you that the most obvious way to build that AI has a massive, dangerous flaw? To really get why, we need to meet let's say, a very particular kind of security guard. I mean, it's a terrifying thought, right? And with a poorly designed system, the answer is shockingly yes. To understand why, and more importantly, how your phone is smart enough to avoid this trap, we need to talk about an extremely overconfident bouncer. So imagine an AI that works like a bouncer at a super exclusive club. This bouncer, he has a list, and on that list are the names of every single person who is ever allowed inside. If your name's not on the list, well, to him, you just don't exist. This is what's known in the field as a closed set system. Now, a system like this operates on a really dangerous assumption. It thinks it's already seen everything there is to see. It lives in this little bubble, believing its training data is the entire universe, and that creates a huge blind spot the second it runs into something or someone new. Okay, let's make this real. Our bouncer's AI has only been trained on 2 people. We'll call them Alice and Bob. It has become an absolute expert at telling them apart. It's got 2 mental buckets, one for Alice, one for Bob, and it is 100% confident it can sort them perfectly every single time. But now, here comes the real test. A new person, Charlie, who the AI has never ever seen before, walks up to the door. Charlie isn't Alice and he isn't Bob, he's a total unknown. So what does our overconfident bouncer do? And right here, this is the critical failure point. The system's programming literally forces it to make a choice. It doesn't have an, I don't know, option. So it looks at Charlie, decides he looks maybe a little more like Alice than Bob, and confidently tosses him into Alice's bucket. It makes a definitive, certain, and completely wrong decision. This whole mess is the core of what researchers call the open set problem. You see, a truly useful system can't just be good at classifying what it already knows. It has to be absolutely brilliant at rejecting what it doesn't know. So how do we build a smarter bouncer? Well, we have to completely change its job description. We stop asking it to be a gatekeeper with a list, and instead we turn it into a cartographer, an AI that doesn't check lists. It draws a map of faces. Think about it this way. The old bouncer asks, "Who are you?" And then he checks his list. The new smarter bouncer asks a fundamentally different question. It asks, "Okay, you're claiming to be Alice. Let's see how similar you are to her reference photo. See the difference?" It's not about classification anymore. It's all about comparison. To pull this off, the AI ditches those buckets entirely and starts using a map. This isn't just any map. It's a vast, high-dimensional space that we call an embedding space. Now every single face it sees gets converted into a set of coordinates and plotted as a unique point on this map. And this face space, as we can call it, has some incredible properties. So, different photos of you from different angles and different lighting, they'll all land really close together on the map, forming this tight little cluster of points. But someone else's face, their photos will form a totally different cluster, far, far away. The AI's whole job just becomes measuring the distance between these points. So what happens to our stranger Charlie now? Well, his face gets plotted on the map too, but it lands way out in the middle of nowhere, nowhere near Alice's clusters and nowhere near Bob's. The AI just measures the distance, sees it's way too far from any known identity, and says, nope, access denied. Just like that, the problem is solved. Okay, but how does an AI even learn to draw a map that's sophisticated? It's not like it's memorizing faces. The secret is, it's trained on a really simple but brilliant concept that involves triangles. This training method is called triplet loss. And what it means is the AI is never to show one image at a time. It's always shown a group of 3, a triplet, and it learns from the relationship between them. So each of these triplets has 3 parts. First, there's the anchor photo. Let's say it's a picture of Alice. Then there's a positive photo, which is a different picture of Alice. And finally, there's a negative photo, which is a picture of someone else entirely, like Bob. Now, the AI's goal here is incredibly simple. Its only job is to adjust its internal map so that the distance between the anchor and the positive gets smaller, while the distance between the anchor and the negative gets bigger. That's it. Pull the similar things closer, push the different things further apart. Now just repeat that process millions and millions of times with all sorts of different triplets. The AI isn't memorizing what Alice looks like or what Bob looks like. It's learning the fundamental general rules about what makes one face similar to itself and different from all others. It's learning the very concept of similarity. So this is the crucial shift, the big idea. We stopped asking the AI a closed world question, who is this? And started asking it an open world question. How similar is this to the person you claim to be? That single changing perspective is this secret sauce behind modern secure face recognition. And that kind of leaves us with a fascinating thought, doesn't it? This whole technique of learning similarity, which is called metric learning, it isn't just for faces. I mean, if an AI can learn to measure the distance between 2 faces, what other complex abstract concepts could it learn to map out and measure? The possibilities are just getting started.